So let's forget about pointers for a while, and let's just copy all that for now. Let's just hide that under the rug. Just comment that. So let's say instead of having these variables that, in this program we want to calculate a lot of rectangles, a lot. So what we want to do, instead of having to keep writing out area equals length times width 100 times or whatever, we instead want to use a function to save some time. So if we wanted to create a simple function, let's say where we've got something called, let's just write it out. So let's say void and print area, and let's go double calculate. I'll explain what I'm doing after I choose what I'm going to type. Let's put that as a void. Yeah, okay. Calculate and print. So actually, let's just... So what I've done before the main is I've declared a few functions which I'm going to define just after this. So what I've got is, on the left, I've got void, which just means nothing, and I've got a double here. So what these left variables represent are inputs. No, sorry. What these represent are outputs of the function. So in this case, this function will return nothing, and this function will return a double. And then on the right, as you might expect, the right is the actual input. So what goes in the parentheses is what the input is. So in this case, it's nothing, or you could also write void, but you can leave it as nothing or void. I'll just leave it as nothing. And then on the right, for the next function where we've got calculate area, we've got double double. So this will take in two doubles, and the next function's also the same, where we've got two doubles of the input. So this is the declarations of the function. So if we want to actually define them, we'll just go under the main, and we'll go print something. Print something, and then that, and just enclose all the code you want it to do in braces. So I'm just going to go, this is something, and let's just clear all this up. So, and I'll just comment out these for now so I don't get an error. So let's just start with this single function here. So all this function does is it prints out this code when it's called. So to call a function, all we need to do is do print something and give it parentheses and put a semicolon at the end. So this will just call this function here. Then if I compile that again, let's just clear it actually. Clear that, and let's recompile, and let's run it. So we've got the function printing out this is something. Very nice. But if I change this to to a double, then if let's give it a 12, and instead let's put double RN as random number, not random in the sense that it's being generated randomly or anything, it's just whatever we choose to put in it. So in this case, we've changed the void as the output, and we've changed the input of the function to a double. So now it takes in value and lets us add it to the actual. So this is something. Let's just put an R in there. And so I compile that, run that. This is something 12. So all good. So let's just get rid of this example. It's just using it to show how to execute a function. So let's put it out into retirement. So let's define these other functions. So calculate area and double. Let's go and oops. So in this case, we've got these two doubles as inputs to the function. So let's just write this out. So calculate slow. Let's have a variable called area, and let's make it equal to calculate big C. So calculate area, and let's give it 7 and 3. Then if we output the area, so let's just compile that. Whoop, what do we do? So 18. Put a semicolon there. Too eager. So let's compile that. Now what did I do? One exit. Some spelling. Oh, okay. I spelled terribly there. So let's just clear that, compile, and run that. So area is 21. Very good. And now let's break this down a bit. So remember, the left is the output of the function and the right is the input. So we're giving it 7 and 3, and then this will return a double. So that's why we can have this area equal to this function, because this function returns a double. So this is pretty much just seen as a double here. So if we wanted, we could also just put the function in the cout. So if we just compiled that and ran it, get the same thing, because this is pretty much just double here. So then finally, I'll just find this calculate area, and just so I don't make the same mistake again, I'll just paste it. So in this case, it takes the same input, so double W and just do the same old. Oh wait, we're doing a void. So we're not returning, this function doesn't return any quantities. So instead we'll just make it print out itself, and we could do it a few ways. We could just go area is whoops, and let's just get rid of that, and let's just call this function calculate area. I'm still scared to spell it, so let's give it the same dimensions, and let's compile that. So again, 21, and also you could just do something like double area equals L times W, and you could just put area here, compile that, just run it. And just to show that this area define doesn't care about the main, so this area only defines in this function that was declared in, that, you know, the compiler won't get angry and say you've got multiple areas, what are you doing to me? Yeah, just to show that these variables can have the same. This area only exists in this main, and this area only exists in this function here. But if I declared an area out here as a global variable, then it would start complaining about me about both these areas. But so from this, you know, we've got all these functions which are related to the same sort of thing. They're doing same thing pretty much. But in the next video, we'll move this into using classes, where we create a collection of functions and variables, and then finally we'll break down this syntax, which we see a lot with Geant4.